So do you remember what we were discussing last time? So last time we discussed some order properties, right? Last time we discussed some order properties. So uh, we discussed these properties last time, right? Am I right?
Yes, sir.
Right. So what we discussed. So if 0 less equal a less than epsilon for then a must be 0. So if a is a non-negative number which is less than every positive number, then it must be 0. So this we discussed last time. Now if a and b are positive numbers, if and only if square root of a is less than square root of b, or if it is less equal, it is less than or equal to a square plus b square. If and only if a square less than or equal to b. This is if and only if that we discussed. Also we discussed that if 0 less than c less than 1, then for natural number n or positive integer 0 less than c raised to n is less than c less than 1. If c greater than 1, then c less than c raised to and it is greater than 1. Now what you can check is, for example, prove that for every n belongs to n, 3 raised to 1 by n is greater than 1. Right, so that you can check easily. Now, what I want, so if you check this, 3 raised to 1 by n is greater than 1 for every natural number n or nth root of 3 is greater than 1. That means 3 raised to 1 by n. So 1 is here and 3 raised to 1 by n is here. So 3 raised to 1 by n is here. For n is equal to 1, 2, 3, 4, 5, whatever you want, you select. Every time this is greater than. So 3 raised to 1 by n is greater than 1. Greater, right? That means 3 raised to 1 by n is 1 plus something, right? 3 raised to 1 by n is 1 plus something. So this something is some additional quantity. Do you understand? This something. Suppose I look at 3 raised to 1, 1, n is equal to 1, and 3 raised to 1 by 1, that is 3. Where is the geometrically, where is this? 1 is here and 3 is here, right? So what is the additional part? 1 plus something here, 1 plus something here is 2. This additional part is 2. Now if n is equal to 2, then what is 3 raised to 1 by 2? 3 raised to 1 by 2 is square root of 3, right?
1.732.
It is somewhere right here, right? Correct? Is it correct? Do you understand what I want to say? 3 raised to 1 by 2 is less than
Sir.
3, right? It is somewhere. So what is the additional part here? Whatever is this, some additional part is there, 1 plus something, because it is greater than. Every time it is greater than 1, so 1 plus something. Now if you look at n is equal to 3, so 3 raised to 1 by 3. So it is somewhere here, right? And so additional part is this. Now, so when I say 3 raised to 1 by n is greater than 1, that means it is 1 plus some additional part. And what is that additional part? Additional part is, you can say, Cn. It depends on n, right? My n is equal to 1, then additional part is 2. My n is equal to 2, then additional part is whatever is this. If n is equal to 3, additional part is this. N is equal to 4, the additional uh, part is this. So additional part depends on n. So I denote that additional part by Cn. Do you understand? 3 raised to 1 by n is 1 plus something additional. That addition depends on this additional depends on what is my n. Correct? Is it clear? Is this clear or not?
Yes, sir.
Yes, sir.
Right. Now, my second question is prove that 0 less than Cn is less than 1 by n for all n. This additional part is less than 1 by n for each n. If you prove this, then this has a significance. What is the significance? If you increase n, every time Cn is less than 1 by n. If you increase n, value of 1 by n is becomes smaller and smaller. At the same time, Cn becomes smaller and smaller, but it will not go beyond 0. So if we increase n, then what happens? So understand geometrically. 0, 1 by n is here and Cn is here every time. Now if you increase n, 1 by n will be smaller, then at the same time Cn will go to this side, right? If I increase n, then it will push Cn again towards 0. If I increase n, then again it will push Cn on this side, and so if I increase n, this will push in this direction. So at the same time Cn will get sandwiched and it will get pushed on the left side. So ultimately my n becomes larger and larger than where Cn will try to reach, right? Where Cn will try to reach.
So it will approach 0.
So Cn will approach 0. That means when I increase my value of n, then Cn will approach 0. And then when I increase my value of n, then when 3 raised to 1 by n will approach
1.
1. So this is a very interesting thing, right? So that we'll learn in detail while talking about sequences, right? But this gives this has a significance. This is a very crucial step, right? So do you understand why this is important? If you increase n, then
S-
can you do
Sir,
same thing for yes?
sir, when we put n equals to 1, then Cn will be equals to 2, and that will be greater than 1 by n.
That will be
Greater than 1 by n.
okay. Yes. Okay, you can say for n greater equal to, right? Is it clear now? Is it
Yes,
clear?
sir. Yes,
Right.
sir.
Now for n greater equal to, no problem at all. Certainly at n is equal to 1, this expression is not valid. But main point is we are worried about what n is larger. What happens if n is larger? So we are worried about when n is larger. If n is finite, some 3, 4, 5, 6, that is not an issue because we can directly see what is it. Right. So what people are worried, people are not worried what is in 5 kilometers away from us. People are worried in the space 1 light year away from us or 100 light years away from us. So people are worried about the long distance. Right. So same philosophy. We are worried when n is larger, then what happens? That which we cannot see directly by our eyes. Right. For n is equal to 1, 2, 3, 4, that we can easily check. But as n becomes larger and larger, so n is tending towards infinity, means it becomes larger and larger. What happens? Right. That is the main point. So we'll discuss this philosophy at the time of discussing sequences. Right. Okay, so you just try to prove this. This is not a very difficult thing. Now I want to generalize this. If you take a greater than 0, then prove that a raised to 1 by n is greater than 1. if not what I want, what I want to say here is A is greater than 1. If A is greater than 1, prove that for all n belongs to prove that so that A raised to 1 by n is 1 plus some Cn, right? This Cn is positive clearly because it is 1 plus some positive. And second point is prove that 0 less than Cn is less than 1 by n for n greater equal to. So this is general. This is something general, right? This will give us some very strong mathematical idea. Right. So you just work out this, why this is true for in this case. Now what is hint here? I will give you hint. What is hint here? So from this 3 raised to 1 by n is greater than 1, that you can check by our previous discussion, right? What is the previous discussion? 3 raised to 1 by n. If 3 raised to 1 by n is less than 1 or less equal to, if you take n power, then 3 will be less than 1. That is a contradiction. That is clear. So this part is clear. If you verify this, 3 raised to 1 by n is greater than 1, that means 3 raised to 1 by n is 1 plus some amount, right? That amount depends on what is your n. If you change n, then this amount, additional amount changes. So that is Cn, C suffix n. Why I am denoting by suffix? Because it depending on n. Right. So from this, now if you take n power of both sides, so 3 is equal to 1 plus Cn raised to n. Right. Is it clear? This is correct. 3 is equal to 1 plus Cn raised to n. If I take n power of this, right, and use binomial. Okay, so idea is clear now. Idea is clear. What I want to say. Idea is
Yes, sir.
right. So some people have kept their mic on unnecessarily. Please keep your mic off. Otherwise, I have to go to the meet and in mute all. That takes time, right? So if you don't want to waste our time, then you should take care of all these things. Anyway, so the problem is clear. What you have to do? Problem is clear.
Yes,
And do
sir.
this. Do this for any a greater than. Right. This is a good exercise. You can just sit down and work out these calculations later on. Fine. Now, at the time of induction, we discussed Bernoulli inequality, which is also essential for further. Right. What is Bernoulli's inequality? Do you remember? Do anybody remember what is Bernoulli's inequality? Then, if x is greater than -1, then
something like 1 plus x whole raised to n is greater than 1 plus n.
1 plus nx, right, for all natural numbers. And this we have already proved in induction, using induction. So this is already proved in some previous sessions. So using induction, 1 plus x raised to n is always greater or equal 1 plus nx. So that you should, and you again write down the proof, right? Proof is just use induction. So why I am leaving you some things for exercise? Because you can understand the things only if you work out on your own. Otherwise, the lots of things are available in many books, right? But that is not useful. It will be useful to you unless you try to solve on your own. So you should use your brain somewhere. Then your brain will get some immunity against such type of difficult mathematical things. So you should work out this calculation. Sit down and do these calculations. Fine, let us go to our next point, absolute value. So what is absolute value? Absolute value is an important property of in the about real. For example, so as according to our previous discussion, what we learned so far, we can arrange all the real numbers on line, and 0 is here. All positive numbers are arranged on right side of 0, and negative numbers are arranged on next negative side. If x is less than y, that means y minus x is positive, then x is on left of y. All these rules are already discussed. Right. Now if you take any real number, right, so let x belongs to R, then absolute value of x is denoted by this notation, right, this bar and x, and is defined as, so how to define absolute value is, absolute value of is x if x is positive minus x if x is negative, and 0 if x is equal to 0. So this is a technical definition of absolute value, right? But basically what is absolute value? So for example, what is absolute value of 2? Absolute value of 2 is 2 plus 2 is positive, and absolute value of minus 2, right? What is x in this case? X is minus 2, and therefore, and x is negative. X is minus 2 and x is negative, therefore its absolute value of minus x. But what is minus x? Minus of minus 2. But by our previous discussion, minus of minus a is a, that is 2, and therefore absolute value of minus 2 is also 2. So if you look at real line and 2 is here and minus 2 is here, so what is the distance of minus 2 from 0? So distance between 0 and minus 2. What is the distance between 0 and minus 2?
2.
2. And what is distance between 0 and 2? Is also 2. So what it suggests geometrically, thus absolute value of x is the distance. So absolute value of x is the distance of x from 0, right? So distance of number x from 0. And what is our usual perception of distance? Right, so what is our usual perception of distance? Right, so question.
Distance never be negative.
Right. So what is meaning of distance? Right, so what is the meaning of distance? So absolute value of x means distance of x from 0 is never negative. That means it is either greater or equal 0. All right. Correct. Second, what is your second observation? What is your usual perception of distance? Distance of x. Thus, let me note here, absolute value of x is distance of x from 0. Right. So, what is a simple another definition of simple another definition of absolute value? Distance of x, absolute value of x is distance of x from 0. So this is what the main point we should remember always, ki absolute value is nothing but distance. So now when distance of x from 0 is 0, when distance of between 2 points is 0,
When x is equal to 0.
x is equal to 0, right? Now third point, absolute value of okay, what is one more property which you should remember? Absolute value of x square is just x square. Do you understand this? The absolute value of x square is just x square. Or let me, before this, absolute value of a into b is absolute value of a into absolute value of b. Right. So, absolute value of x less than or equal to a if and only if minus a less than or equal to x less than or equal to a. Right. Sixth, absolute value of a plus b or x plus y, it is just notation. So less than or equal to absolute value of a plus absolute value of b for any a and b real numbers. So these are the some of the one more. I think I should note that also. Absolute value of x greater than or equal to a means x is greater than a if a is positive and x is less than minus x is less than a if a is negative. So these are the greater equal actually here. These are the properties of absolute value. So we'll see one by one, and some of them are trivial.
Sir, is this absolute value is the same as the mod function we use?
What do you think?
Sir, this absolute value is the same as the mod function we use, like the definitions are same for both.
Now, what is your answer? What do you think from this?
So I think the same, but we haven't learned the distance part in mod function.
Yes, whatever you learn in the 11, 12 or school, you just learn the notation absolute value, but nobody told you this is a distance. Right? This is what we
Yes,
use
sir.
in our day-to-day life, and your teacher were are supposed to told you in your when you were in school or 11, 12, but they didn't tell you. Right? That is the problem.
Yes, sir.
मध्ये मॉड म्हणजे मॅग्निट्यूडच डोनेट करतो ना, तो मॅग्निट्यूड बेसिकली डिस्टन्स नोटेशन.
This is actually magnitude, or magnitude is a something generalization of same fact in vectors, case of vectors, right?
Yes.
So magnitude is a something general word, general. Now you are in space, then you have vectors, then magnitude. So length, that is again kind of distance, but that you can learn later on. In second year BSc, you will learn some generalization of these facts. We are just studying very basic case, real numbers, particular case, real numbers, and it has generalization. And where are these generalizations occurs? These generalizations, of course, you have to learn at in due course of time. You have to learn the generalizations of all these basic concepts, and where these generalizations occur in every field of life. For example, in physics, electronics, chemistry, whatever, wherever you go, you have to apply same ideas in general manner. Right. So, for example, you have to solve some problem in space science, then you have to formulate that problem into mathematical model, and once it is formulated in mathematical model, you have to apply mathematics theory, and while applying mathematics theory, you have to apply all the mathematics that you are going to learn in future. Right. So that mathematics means what? It is just generalizations of these facts, whatever you learned so far, generalize. Here you are saying magnitude, that is right, magnitude on real line, but you are in space, then what is the magnitude? So it is a magnitude of vector, but that is the, what is the way to measure the magnitude of vector? Again, that is a different thing, because there is no unique way to measure the distance. Right. Suppose uh, I am saying here distance because it is our usual perception of distance. Right. But suppose you want to measure the distance of Pune from Mumbai. How will you measure the distance of Pune from Mumbai? Do you understand the question?
Yes, sir.
How will you measure the distance of Pune from Mumbai?
So we'll take one of the place as the zero and measure the distance of the another with respect to that.
But how? What technique you will use? You know, 2 points. That is fine. What technique you will use? Right. When you are traveling by car, then you are saying, okay, distance and Pune Mumbai is 150 kilometers, for suppose. But if you are going by aeroplane, then you are saying no, distance is only 100 kilometers. Right. If you are,
Yes.
so you are going by train now, you are saying distance is 110 kilometers. Right. So what does it mean? There is no unique way to measure the distance. There are different ways to measure according to your requirement. Do you understand? And that is what you are going to learn in further mathematics, in second year, third year, or higher mathematics. What is the generalization of our usual way to measure the distance between 2 points? Suppose you want to measure the length of your room, whatever room or hall. What you do? You just take a straight line, tape, and then you measure. So this is your usual way. This is our usual way, right? That is called as a Euclidean distance. What is the Euclidean distance? You take straight line distance between 2 points, measure straight line distance. But it is not necessary that every time straight line distance is a distance, right? Therefore, what is your visual perception of distance? Non-negative. It is zero. That we'll see later on. Anyway, so that we'll see later on. What are the basic properties of distance? Anything that fulfills the properties of distance, that is a distance. But for our daily practical purpose, we use a straight line distance. That is a Euclidean distance, because Euclidean geometry based on this kind of measurements. Right, when you measure the sides of triangle, when you measure the area, right, in Euclidean geometry, whatever you learn in the school or so far is Euclidean geometry. But there are different kinds of geometries. Anyway, but right now, as a beginning, we should learn what is a basic usual thing, right? Fine. Okay, so distance is greater equal 0, that is clear from the definition, because if x is negative, we'll just multiply by minus, so it is positive. So from definition, so first thing is clear. Clearly, by definition of absolute value, right? Clearly, absolute value of x is greater or equal 0 by definition of absolute value, because if it is negative, then absolute value is minus of x, so it is again positive, so it is greater, and if x is 0, it is 0, so it is from definition, it is always greater or equal 0, right? Also, absolute value of x is equal to 0 if and only if x is equal to 0 by definition, right? If x is 0, then only absolute value is 0, otherwise non-zero. That is also clear just from definition. What is the next? Okay, so first we'll prove fourth and then we'll go to the third, and that will be easy, right? So first we'll prove fourth. The absolute value of a into b is equal to absolute value of a into, what is our claim in fourth? Our claim is okay, what is our claim? For any AB belongs to R, absolute value of A into B is equal to absolute value of A into absolute value of B. This is our claim. Now you can make cases. What are the possibilities? So let I will choose arbitrary element set of real numbers. I will just close my eyes and I just put my hand in the set of, suppose there is a bag containing all real numbers, right? Right, this is a bag containing all real numbers. I will just close my eyes and just put my hand inside bag and I will choose two numbers, right? Without any bias, I just select this particular and this particular B, which is convenient for me. Without looking at our convenience, just choose arbitrary. So whenever I say let AB belongs to R, means what it says is not particular, just choose any two. Just close your eyes and select any two numbers. Okay. Then what is the first possibility? Either both are positive. This is the first positive. Then case 1. Okay, let me say case 1. What is my case 1? Both are positive. Then by order properties, A into B is, by order properties, A into B is
Greater than 0.
positive, right? Now reason is there, because whatever learned so far, from that reason we can definitely say that AB is positive. Therefore, what is absolute value of AB? Is AB, because by definition absolute value of positive number is itself. But what is A? A is positive, so what is absolute value of A? Right? When I say A is positive, absolute value of A is A and absolute value of B is B. Clear? And therefore A is same as absolute value of A and B is same as. So therefore I can replace now A by absolute value of A and B by absolute value, because they are same. And thus in this case it is clear, right? Now
Yes, sir.
what is case 2? What is second case? A positive and B negative. Then what is absolute value of A is A, absolute value of B is absolute value of B is
B.
minus B, right? Because B is negative.
B.
Also, what is product AB? Product AB, A is positive, B is negative, then product AB is
Minus AB.
negative,
Negative.
right? And if minus AB is yeah, AB is negative because A is positive, B is negative, the product is negative, and therefore what is absolute value of AB? What is absolute value of negative number?
Minus of
Positive.
Minus of AB. Very good. But I can write it as A into minus B. I am allowed to write this, right? By our previous discussions. Correct? But what is A? A is absolute value of A because A was positive. What is minus B? Minus B was absolute value of B because B was negative. So again, absolute value of AB is equal to absolute value of A into absolute value of B. Am I right?
Yes, sir.
Now case 3. If one of them is positive, another is negative, same is the A negative and B positive. What is the next case? Both are negative. Right? One of them is both are positive, both are negative. One of them is positive and another is negative. That is the same case when A negative and B positive. So we should not treat it separately. Then absolute value of A is
Minus A.
minus A. Absolute value of B is minus B.
Minus B.
And what can you say about AB?
Positive.
AB is,
Positive.
and therefore what is
Greater
absolute?
than 0.
So absolute value of AB, since AB is positive, it is AB, right? But I can say that it is minus of minus AB. Am I right? Recall this, for any real number, minus of minus A is A. This is true for whatever is your real number. Correct?
Yes, sir.
So therefore for AB also I can write it is minus of minus AB. No problem. Now I will assign this minus sign to this A, and I will assign this minus sign to this B. Am I allowed to write this? Do we have sufficient reason?
Yes, sir.
Right. Because we already proved all such kind of things in before. But what is minus A in this particular case?
Absolute value of A.
Right. And minus B is absolute value of B. And therefore, absolute value of AB is absolute value of A into absolute. Now, which case remains to consider? Which case remains to consider?
One of them
A
is
is
0.
negative and B is positive.
That case is already discussed, similar to this, right? Second case. One of them is negative, another is positive. It is similar case. Only the
A
role of
is
One
A
of
and
zero,
B
B
will
is
be
equal.
changed. That's
one of
one
them
of
is
them is
0.
The zeros.
one of them,
One of them is 0.
right? So that is either A is equal to 0 or B is equal to 0, right? Then certainly product is 0. Whichever both are 0, then product is 0, no doubt. But if one of them is 0, then product is 0, right? If one of them is 0, then what happens? Absolute value of A is 0 or absolute value of B is 0. That is clear. But then product is also 0. Therefore, absolute value of AB is 0, right? And absolute value of A into absolute value of B, either this is 0 or this is 0, then this is also 0. So therefore, this is absolute value of A into absolute value of B. So absolute value of AB is 0, which is absolute value of A into absolute. So therefore, in any case, right, no case is missed out, because you can say A negative, B positive, and B positive, A negative, or A positive, B negative. So that is not distinct case, right? Because we are arbitrarily choosing A and B, not any special A and B. So therefore, it is true. Thus, what is the conclusion of all these four cases? Absolute value of AB is same as absolute value of A into absolute value of B for any real numbers A and B, right? Equal to, so this is our fourth part of theorem. Now third part is obvious. Why? Third part is obvious. So Absolute value of, okay, what is third part? Absolute value of x square is x square. Absolute value of x, its square, right? This is what absolute value of x into absolute value of x by fourth part, correct? But by fourth part, what is it? Absolute value of x, its square means absolute value of x into absolute. By fourth part, what is it? Absolute value of x into x, right? Am I right? Am I right? This is correct. What I am
Yes.
using here?
So,
What I am using here? Absolute value of a into absolute value of b is absolute value of ab. This is what I am using here. The a, b, absolute value of x, absolute value of x is same as product, absolute value of product. But this is same as absolute value of x square, right? But we know that for any real number, x square is greater equal 0. Whatever is a real number, positive, negative, now it matter.
yes,
Now
sir.
what is absolute value of x square now? Is it x square?
X by
Correct. Fine. Therefore, absolute value of x square is just absolute value of x, its square is just x square. Fine. Now, what is next part is absolute value of x is less equal a. Suppose absolute value of x is less equal a, and what is our claim? Now, absolute value of x is, we know that when I say absolute value of x is less equal a, that means, and already we know that absolute value is always greater equal 0 by previous discussion. That means a is certainly positive, right? This is clear, a is greater equal 0. So what is our claim? Minus a less than or equal to x, less than or equal to a. This is our claim, right? So x lies in between minus a and a. This is a claim. So how to do this?
We should take cases x less than 0 and x greater than 0.
Case 1. What is case? Suppose x is positive. Then absolute value of x is x, right? And therefore absolute value of x, this is our hypothesis, assumption. So less equal a is equivalent to saying that x is less equal a, but already we are assuming that x is positive, right? Already we are assuming that x is positive, so it is greater equal a, positive, or you can say strictly positive. No problem, I can say x is strictly positive, then it is strictly greater than 0. In case of 0, absolute value is 0, that is not an issue. Now what is case 2? Right, so if x is positive, then x lies in between 0 and a. If x is positive and absolute value of x is less than or equal to, then x lies in between 0 and a. Now if x is negative, then absolute value of x is minus x, right? Therefore, what is our hypothesis? Ki absolute value of x is less than or equal to a implies minus x is less than or equal to a. Correct? Am I right?
yes, sir.
Now, if I multiply by minus 1 on both sides, what happens?
The
If I
inequality changes.
right, then x greater equal minus a. Why? By order property. If a less than b and I multiply by negative numbers on both sides, then inequality reverses. So therefore, ultimately what happens? E minus a less than or equal to x. Right, so minus a less than or equal to x. But already we are choosing x negative, so this is. right? That means if my x is negative and it satisfies this condition, which condition? Its absolute value is less than or equal to a, then certainly it lies in between minus a and 0. It is here. So what is the combination of these two cases? Right, from this figure, what is the combination? Thus, or third case, you can say that x is equal to 0. If x is equal to 0, that means absolute value of x is 0, right? So in that case, it is clear it is 0. So what is the combination? What is the conclusion? Thus, what is the conclusion? What is the conclusion? Absolute value of x is less than or equal to a implies no matter your x is positive, negative or 0, in any case, if x is positive, then it lies in between 0 and a. If it is negative, it lies in between minus a and 0. And if it is 0, then it is 0. So what is the conclusion? Absolute value of x is less than or equal to a implies minus x minus a less than or equal to x less than or equal to a. Is it clear now? This is clear.
Yes.
Yes.
Now conversely, suppose minus a less than or equal to x less than or equal to a. What is our claim? Absolute value of x is less than or equal to a. This is our claim, because our statement, if you go back to the statement is if and only if, right? If and only if this implies this implies this. So if and only if. So what is the converse way? When x lies in between minus a and a, then absolute value, that means its distance from 0 is less than or equal to a. So when I say that minus a and x 0 is somewhere, right, and absolute value x lies in between minus a and a, so what we can say? This is our assumption, right? X lies in between minus. So case 1, if 0 less than x less than or equal to a, then x is positive, then absolute value of x is x, and therefore ultimately uh, absolute value of x is x less than or equal to a. So this inequality hold for this part, right? Case 2, if minus a less than or equal to x negative, suppose x is negative, then what is absolute value of x is minus x. Absolute value of x is minus x, and what we say, so therefore what you can say now, what you can say
Minus
now,
x is greater than minus a.
so minus x, okay, I can say that minus, if I multiply both sides by minus 1, then absolute value is equal to x minus of absolute value of x is equal to x, so that minus a less than or equal to x, right? That is our x, but x is same as minus of absolute value of x, right? Now multiply, so ultimately what we get here, minus of absolute value of x is greater equal minus a, and multiply both sides by minus 1, so what happens? Absolute value of x is less than or equal to a. That is what we wanted to get. Therefore in any case, minus a less than or equal to x less than or equal to a implies absolute value of x is less than or equal to a. Now you just observe these calculations are not very difficult calculations, just elementary calculation. The only thing is you have to do it carefully, right? So is this clear now?
Yes.
Okay, very good. So what we learn, okay, absolute value of some number is less than or equal to some positive number a if and only if that number x lies in between minus a and a. That is if and only. So the next property is most essential, very important, right? So triangle inequality. So triangle inequality. Why triangle inequality? So for any xy belongs to R, x plus y is less than or equal to x plus absolute value of y. Okay, why this is called as triangle inequality? So let me tell you something which you already know. If this is my vector u bar, this is my vector v bar. Now, can you tell me vector u bar plus v bar? This is also u bar. I just put this vector. So, do you know this is vector u bar plus v bar? Am I right?
Yes.
Alright. So this is vector u bar plus v bar because you have already done such kind of things. Now, what is the length of u bar plus v bar? Magnitude of this vector u bar plus v bar. And if I sum the magnitudes of u bar and v bar, which quantity is bigger? Which quantity is bigger?
The sum of two sides, u bar, magnitude of u bar and magnitude of v bar.
Right, very good. So the length of this vector u bar plus v bar is always less than or equal to the sum of lengths of these two vectors. Right, and why this is called as triangle inequality? Because if you have a triangle, right, and this is my triangle ABC. If length of this side is A, this side is B, this side is C, then length of this side, one side, length of A is always less than or equal to length of length. Actually, this is a length, right? I am saying length. So A is less than or equal to B plus C. So length of one side of triangle is less than or equal to sum of lengths of remaining two sides. That is what the triangle inequality in case of vectors. So length of one side of triangle is less than or equal to sum of lengths of remaining two sides. So that's why this is called as a triangle inequality. Right, and this is a very important property satisfied by distance. Do you realize this is satisfied by distance?
Yes.
Right, because suppose this is Mumbai, Pune and Nasik. So distance of Pune from Mumbai is less than or equal to distance of Pune from Nasik plus distance of Nasik from Mumbai. Right, if you want to go from Pune to Mumbai, which path you will prefer? You will prefer this path, Pune to Mumbai. You will not go to Nasik and then Mumbai because this would be the larger, right? Economically, this is not convenient, right? That's why triangle inequality we are using in our day-to-day life. You are going from your home to college, which path you will prefer? You will prefer, suppose you are coming from Hadapsar, then you will not go to the Nashik Phata and then will come to the college, or you will not go to the Pimpri Chinchwad and then will go to the college. So you will prefer the path which is direct. This is due to triangle inequality, right? And therefore triangle inequality has a very special meaning over our daily life. So that's why this absolute value satisfies. Okay, so proof is easy. So let x and y are any two real numbers, right? Then we have from previous discussion, what we have, absolute value of x and absolute value of x. What is the relation? What is the relation? Same x. You understand? And don't get confused. I am not writing anything very difficult. And answer is easy. When answer is easy, people get confused. How answer can be very easy? So if answer is easy, then believe that it is easy.
They are
Right? So what
equal.
is equal? So answer is very easy, but still people get confused. How should I say it is very easy? Right? So, but there is no harm in saying that it is less equal. Am I right? Am I right or not?
Yes, sir.
Can I say that 2 is less equal to?
Yes.
Right, because I am saying that 2 is then 2 is equal or less. I cannot say 2 is less than 2. This is not. But I can certainly say, because this is union of two conditions, either less or equal. So one of them condition is true. So this expression is true. Fine. Now compare with previous. Absolute value of something is less than or equal to absolute some number a, and this number is non-negative definitely because it is absolute value. So can I compare with this? And what is my a now? This number. The situation is like absolute value of something is less than or equal to some non-negative number. My non-negative number is absolute value of x. I am just looking at particular x. Right? Can I compare this? And what is my next step? I am not violating any law of mathematics, rule of mathematics. I have to obey all the rules. But and whatever the results I want to use, which are true. Okay, so what I should write now next? Absolute value of something is less than or equal to some non-negative number. Then what can I say?
Minus of x is less than or equal to x and less than or equal to x.
Absolute value. Right? This is correct now. This is correct. And this is clear. You choose any x. You choose any x. If x is positive, absolute value is same as x. And then minus of absolute value is still negative. In this case, this is true. Suppose my x is negative. Suppose x is here, absolute value of x is minus x. Right? Then minus x is positive on this side. In that case also this is true. So no matter what is your x, the any real number always satisfies this. And similarly, minus of absolute value of y is less than or equal to y, less than or equal to absolute value of y. Is it true? Is it true or not?
Yes, sir.
Now I have two inequalities. I have two inequalities. Add these two inequalities and see what happens. So you just think over it, because at this it is 2 o'clock. So I think I should stop now. But you just